What's up, YouTube? It's your boy. I just want a bev.
All right. So the first one, we're going to change it to 330 degrees radians
I just want a bev.
into radians.
The whole entire time you're still giving me after a bev. My throat hurts. Please, can I have a bev?
Rest your throat.
No, please. I'm going to do this the whole class.
330 degrees.
Please, I'll be good the rest of the class. 1 minute, let me get a bev. Literally.
I already told you the cost of getting a bev. Don't forget it. When you change 330 degrees into radians, remember, since you're going to radians, you put pi on top and put it over 180. Okay? This section of the test will be a calculator section. So you're allowed to use a calculator during this section.
Sam Steiner, go get a bev. You heard that?
So it's going to be reduce as much as possible. 0, 0. You could take out a 3, so that's a 6. That's a 11. So this turns out to be 11 pi over 6.
Yo.
That's can I be the whole test, please?
Yo,
Next one, 5 pi over 6 to degrees. So in this situation, you're going to change 5 pi over 6 to degrees. So we're going to do 5 pi over 6 times, since we're going to degrees, 180 is on top.
Would it say like this 2 degrees or like word?
It would have the word change. It'll say change 330 degrees into radians. That's what it says. Change 5 pi over 6 to degrees. So then over here, we reduce as much as possible. 1 and 30. We could cross out those pi's. So it becomes 150 degrees. Okay. So easy freebies. Don't leave those behind.
Okay, what do you want?
Next one.
What do you want?
We can go back.
Oh, yeah, sure.
Which one?
Any of those guys, I'm mad.
You want a vitamin one?
So you only write this down.
They just
No, I didn't.
Next one.
yeah.
If I tell you
want any?
sine of theta equals 12 over 13,
Light water, apple juice.
what's tan of theta?
Give me 2, please.
Two?
Thank you.
Well, that's
You can
light
put
water.
whatever on the tab.
So in this one, we have a right triangle. Doesn't make it matter where you put the theta,
You did.
but make sure it's based. So in this one, it's sine, or so from SOHCAHTOA, which means the opposite should be on top, 12, and the hypotenuse should be on the hypotenuse, 13. So in this case, you want tan. Tan is TOA, so TOA. So we need an opposite over adjacent.
Is it 5?
So in this one, if you do the Pythagorean triple, it is 5. If you don't know the Pythagorean triple, you have your calculator. You could do 12 squared minus 13 squared, or other way around. Either way, you found out it's opposite over adjacent. So tan of theta must be opposite 12 over adjacent 5. Good. Next one. If cosine of theta is 4 over 5, what's cosecant of theta? So this one's the same one. Just remember, cosecant is the reciprocal of sine. So while sine of theta is opposite over hypotenuse, cosecant theta is hypotenuse over opposite. Otherwise, you do the same thing as the previous question. Make your triangle. Theta goes wherever. Since it's cosine, it's going to be adjacent 4 over hypotenuse. And this one will be 3. If you don't know, you can always use Pythagorean theorem.
So it's got to be 5 over 3.
So in this case, because yours is hypotenuse over opposite, it's going to be hypotenuse 5 over the opposite 3.
That was candy. If you think apple juice not in the fridge.
What?
For the next one,
Shoot, is that
you got some right triangle. This is 4. This is theta. Oh no. We put the actual number. Let's put 32 degrees, and this is x. Find the area. That's David Gross. Find the area, or find the x value here. I'm sorry. So to find the x value, you need the opposite here. So this is the opposite, and this is the adjacent. Oh man. Adjacent. So then you're going to say, oh, opposite adjacent, that must be TOA. So that's tangent. So tangent of 32 degrees, the angle goes inside the tangent, equals opposite, I don't know what that is, so x, over adjacent, in this case 4.
4 times 10.
Good. So then I'm going to multiply 4 on both sides. Type into my calculator. In this case, since you put degrees in the tangent, your mode should be in degrees. Otherwise, you're going to get the wrong answer.
It's like the.
Degree symbol's there, put it in degrees.
But if it's not radians.
Then it's radians, so.
Wait, what do you mean? It's 10, 32 degrees.
32 degrees. You make sure it's, the calculator knows it's in degrees.
And what about for radians?
It wouldn't have a symbol like that. Or not a degree symbol. So, mine's is in degrees, thankfully. So 4 times tan.
Every question I'm asking.
32. I'll tell you if your calculator's in the right section. Steiner, get back in.
Can I just go out for 1 minute?
No.
I need
4.5. What was it, 4.5? Oh, no,
Can I go to the
2.5.
bathroom?
No.
I'm just held hostage here the whole time.
Sit down. So 2.5 is your answer here. We have the reverse type of question here. I guess I could do it on the same page. Where we have a right triangle. Let's say the theta's up here this time to mix it up. And let's say this is 10 and this is 3. In this case, your theta's up here. So make sure if your theta's up here, this is your opposite in this case, because it's opposite of theta, and this is your hypotenuse, which uses opposite and hypotenuse, so, or sine. So this is going to be sine of theta equals 3 opposite over hypotenuse, 10. I need to get the sine away from the theta. So what I'm going to do is sine negative 1. What I'm going to do over here is sine negative 1.
Why is that? Get rid of it.
They're inverse
Just skip
function, like the opposite of square and square rooting.
Just go sine negative 1 first.
You could just go straight to that now, okay. So then it is theta equals sine negative 1, 3 over 10. Just make sure if your mode's in degrees, you're going to get out degrees, which makes sense because we're talking about actual triangle. So sine.
No, but doesn't it give you an answer in degrees?
Yeah, it's in degrees.
Rihanna,
Also.
my drink right there. She's just talking to someone. I'm just going to scream.
No. Well,
Yeah.
3 divided by 10. 17.4. So, well, I guess it rounds to 17.5. So this is 17.5 degrees.
So when angles involved in the original equation, then it's degrees, and if it's not, then it's radians, basically?
That's a fair, yeah. You could do it. Usually if I'm talking about an actual triangle, I would like degrees. Typically if I'm talking about like what is the value at, or evaluate sine at, let's say pi 3 over 2, then that's a radian thing.
How many questions do you have?
I can answer that. Give me a second.
No, I told you.
Also, like,
15 in total.
We have all of
it's
mine.
like the unit circle on it. Like
Yes, that's the non-calculator section.
So,
Yeah. Oh, well, the next one we're about to do is give me a positive and negative coterminal angle to, let's do 2 pi over 3.
On a scale of 1 to 10, 10 being the hardest, 1 being the easiest, where do you rate the test?
How much do you know trig from last year?
This is my best subject.
The way you did,
Me.
like, the way you, like, customized the test, like, how...
It depends how good are you with trig. If you feel like you,
Individual, like,
I mean, that's
do the mark-
how life is. If I give it to my academic, they will do
You
crappy.
judge it based off accelerated in 11th grade. Like, what
I think the test is easy for this level, but if you don't know your unit circle, it's impossible. If you don't know like the radian to degrees, impossible. So you got to know your things. But after you know the
everything, like if we
then I don't know.
take a test on the ABCs, if you don't know the ABCs, it's impossible. Like
Okay. Like I agree.
okay,
So no, 2 pi over 3
I know
Plus-
I gotta pee.
now. What's a full rotation in radians though?
Did I do something wrong that I can't go
2
back?
pi. So you're going to add 2 pi. This is over 3 though, so I don't want to add just 2 pi. I'm going to change it. So 6 pi over 3.
Yeah.
Because 2
when
pi.
you do the
Can we
calculation,
turn it into degrees and add?
That's fine, but since I gave you my question in radians, you need to give it back in radians. So as long as you're willing to convert and then convert back, that's fine. Either way, this is going to be 8 pi over 3.
Welcome to class.
Thank
Oh,
you.
wow.
Thank you.
And then the other one is negative. So instead of adding 2 pi or 6 pi over 3, I'm going to subtract 6 pi over 3.
Which
Need to
equals
pee.
Negative 4 pi over 3. So those are your answers for this one. You found a coterminal angle that's positive and a coterminal angle that's negative.
Oh, let's simplify the denominator to the top.
Okay. What?
You multiply the denominator
Oh.
to 2 pi to get the numerator of the other one.
Yeah, yeah.
I need to pee.
No.
now we go to the bathroom.
No. Number 7. Oh, wait. Next one. So that's coterminal angles. We're going to talk about reference angles.
What's that?
How many questions is this?
15.
Huh?
15. So 7 pi over 6, let's say.
May I please go to that?
Now, in radians, it's kind of actually easy.
Go right here, son.
I'll leave my phone and my bag.
No. Sit down.
I'll literally leave everything but what I need to pee with.
No. So 7 pi over 6, we need what the angle is
I need to pee.
of the first quadrant.
I still need to pee.
So 7 pi over 6, either you could always turn it to degrees and go it back. I'm going to do it on radians though. The rotation is 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi over here. So in this case, 7 pi over 6, you should note, oh wait a second, this is definitely bigger than 1 pi and smaller than 3 pi over 2.
Why can't we just make it into degrees?
You could turn it into degrees and then convert it back to radians at the end. But if I give you radians, I want my answer in radians. If you give me your answer just in degrees, I will take a point off. So make sure you convert twice, basically.
Yeah.
I'm not going to make you, well, I'm going to
How
do
would
it,
you convert after degrees? What would you do for after?
you just do 180 over pi. If you were able to do question number 1, you were able to do that.
Oh.
So in this case, you know it's over here somewhere.
How?
Because 7 pi over 6,
Oh,
it's bigger than 1, but less than 1.5. Because this would be 9 pi over 6.
Oh,
Yeah. Okay. So with that in mind, you know it has to be here. No.
Why then?
So in this case, 7 pi over 6, what occurs here in this situation is that I want to figure out what this part of the angle is. Technically, what's occurring is I'm going all the way around here. I'm going all the way, long way around. So I just want this piece right
More
here.
than 180.
So what I'm going to do is subtract this part in purple over here.
That was so smart of me.
So I'm going to subtract pi. I'm going to subtract pi. Let's make it the same base. So 6 pi over pi, or 6 pi over 6, my bad. Which means we subtract
Then
that.
why'd you do
The
6?
reference angle is pi
Wait,
over
but where'd
6.
you get 6?
It's 6 here, so I just made the 6.
If it was like negative 7 pi over 6 at first, it would.
It would land over here, and you were going this way, so you could technically have to add a pi, I guess, because you got to go backwards. You know what I mean?
You would start the other way.
Yeah, you would be going downwards.
Yeah.
Yeah.
So if I got
But for the reference angle ones, I'll keep it
I've
positive.
actually never need people.
so this is 210. It's 210 degrees, and then what we do after that?
You could subtract 180,
Right.
and you will get 30, and then convert that back to radians.
Oh, okay, fine.
I offered
No.
that. I offered to leave
No.
everything.
No.
I couldn't pee in my pants.
I'm good at this.
Sit
I have
down.
the balls to do it. Like I will.
Abby, no.
Oh, did I do this?
No, throw that away too.
I'm a boy. You can do it.
What's
You
the
don't.
what's on you?
Sit down.
PA card.
And I,
Word.
Next one, number 8,
Card for PA.
is 30-foot ladder.
And P.
No, don't be crazy. Just say those words to a man.
Can I pee? You're just letting her walk scot free.
No, come back and sit down.
it's so much closer to the place.
Sit down. You're wasting time. It's on the recording. Now it's like embodied forever. As long as YouTube is alive, this conversation.
I'm about to pee my pants. I did this on purpose. This was not an accident. What do YouTube?
No, sit down. So, this one, let's say 30-foot ladders leaning on a house. Let's say it's the bottom of it
I'm gonna start doing the PP dance.
is 15 feet away.
We'll both be back in 2
That's a
minutes.
pretty long.
All your troubles will be gone if you just let me pee.
Oh, you have to sing APCs twice.
3 minutes starting now.
Yes. Thank you.
Damn, 3? Wait, he hooked you up. I can't run it.
Luckily, it's closer. So, 30-foot ladder, the bottom's 15 away from the base. What is the angle at elevation? So, it's literally the questions you did earlier. It's just that you have to kind of draw it out. So, here's your ladder.
I'm just gonna make it a
Here's your horrible barn. And then here's the distance. So in this case, the 30-foot ladder's over here, 15's over here. You've got to find theta. Okay?
How do you know where to place theta?
It's always off the ground. Theta's always off the ground. Well, it says angle of elevation. So,
Also elevate.
yeah. So this one, you could actually figure out what this one is without using a calculator. But you could also do, not sine, I'm sorry, cosine, because it's adjacent.
But how can you figure out it's not packed?
I'll show you. Cosine of 15 over 30. And then theta equals cosine negative 1. I'll just reduce it to 1 over 2. Another way you could figure it out is, wait a second, if this is half of that, this must be a special triangle. This is actually a 30-60 triangle. Because if you remember, if this is 30 degrees, this is a right angle, so this must be 60 degrees. Either way, if you type this in the calculator or you figured it that way, you should get 60 in this case. I'm not saying on the actual test it will be a special right triangle, but, you know, it could happen.
Good time.
Yeah. Number 9.
How much do so on eight?
What's cosine of theta at, let's do 4 comma negative 3. So 4 comma negative 3, just to visualize it. I don't give you a grid on this, so if you want to draw a grid to help you visualize it, that's fine. But 4 comma 3 would be 4 right, 3 down. So it'd be some line this way, where this will be your theta. You remember, your theta always comes from your x-axis. So in this case, it's coming from the x-axis. In this case, 4 is how far you went to the right, and negative 3 is how far you went down. A little bit of Pythagorean theorem will get you 5. In this case, I'm looking for cosine, so adjacent over hypotenuse. So it's going to be adjacent 4 over hypotenuse 5. So cosine of theta is 4 over 5. Remember, in these type of questions, technically the answer could be negative, so be aware of that. In this case, it's positive, but if I did sine, let's say, it would be negative 3 over 5. That would be a negative answer.
Wait, you don't want the actual, like, degree?
I didn't ask. No, I just want cosine of this thing, which is the ratio.
If it was the degree, you do the 180.
No, you do cosine negative 1. You ran out of time. It buzzed already.
My alarm didn't go off.
You put a...
Silent.
My alarm didn't go
We're Stein
off.
making.
See, I had 12, this is later.
I'm saying Willie made it.
You're already late. 3 minutes already passed.
Already, that's why I ran.
3:30. Work on it next
Piss
one.
of my life.
All right, next one. Number 10. Find cosine theta given cotangent is a theta is 5/12 and sine of theta is less than 0.
You want to disturb or what?
Sorry, sit down.
That was not nice of you.
Oh, all students think about it.
Wait, and sine is what?
Less than 0.
So it would be.
So in this scenario, we have cotangent or tangent being positive. So cotangent being positive has to be in quadrant 1. All students take calculus, or quadrant 3. Sine being negative has to happen in quadrant 3 or quadrant 4, which in this case, where's the only quadrant where both of these could be true at? Quadrant 3. So we know our angles over here.
Good job.
Now, in this case, cotangent, here's the theta over here. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. So this must be a -5, and this must be a -12. Yeah, what's up?
Wait, but sine is less than 0.
So it has to be, sine would be negative.
In 1.
Sine would be negative. Sine is positive at A, where all are positive, or
So
S.
-5/13.
Yeah, but doesn't.
Oh.
It doesn't less than like move back with motion.
Sine is smaller than 0, so sine is negative. Whatever result you get here is negative. All right, your hypotenuse is always positive, either by Pythagorean theorem or knowing that it's a distance. Either way, it will be 13. There's a 5, 12, 13. Get used to those triangles. In this case, this is a, what are we looking for? Cosine. Cosine is adjacent over hypotenuse, so -5/13. All right. So on the test, there's a calculator section. All those questions were within the calculator section. Not necessarily all of them need a calculator, but some of them do. This is the non-calculator section. How the test will work, I'll give you a calculator section first, then you bring up your calculator and I'll give you the non-calculator section. So you keep both half of your test all the whole time until you hand it in, okay? All right, so non-calculator section. So first one, you want to evaluate tan pi/6. Okay? Now, there are two special right triangles. The first right triangle is the 45, 45, 90, and the second one is the 30, 60, 90. I'll put 30 on the board.
What do you mean evaluate?
Evaluate. You're going to tell me what the answer is without a calculator, what tan pi/6 is. There's, if you want to, sure. But remember, you won't have a calculator section, so this one's easy, but
Yeah.
let's be careful. All right, so there's the 45, 45, 90, which is, in this case, if it's a unit circle, this is 1. This is going to be √2/2, and this is √2/2. And then the 30, 60, 90, if the 30 degrees, or if the hypotenuse is 1, the 30 degrees will be a half, and the 60 degrees will be √3/2. Let's see if I can get this one.
So is it 1.5/2?
So one way you could do it is remember just remember all the values of the unit circle, or you could use the right triangle here. So pi/6, you can figure out that's 30 degrees.
Yeah.
30 degrees, and you should also know 30 degrees is in the first quadrant. So you know the answer should be positive. 30 degrees produces a half result. So, or I'm sorry, tangent is opposite over adjacent, correct?
Yeah, so it's 1/2 over 2.
Yeah, so it's 1/2 over root 3 over 2, which you could count out the halves. 1 over root 3, which you have to rewrite as root 3 over 3.
Wait, half. Would you have to do that 1/2 over root 3 over 2?
You could cancel out because they're both halves on the bottom.
Oh.
So it's 1 over root 3, which then you got to rationalize root 3 over 3. All right.
Wait, how would you do that 3 degrees?
The only way you would do is if you remember all the unicircle.
Degrees.
Okay. Next one. Evaluate sine. Let's do 135. Let's see if I can copy this in. So in this one, this is not within the right triangles. So again, if you remember the unicircle, that's fine. But in this situation, what you could do is sine 135. It's this one I gave you in degrees. This one,
180 minus 135.
you could do 180 minus 135. You need to understand that 135 must be in the second quadrant. So to find a reference angle, you do 180 minus 135. That's going to be 45 degrees. Oh, wait a second. I know what is sine at 45 degrees. That's opposite over hypotenuse, or root 2 over 2. Root 2 over 2 divided by 1, which is just root 2 over 2. Again, you can either remember the unicircle, or you could do it based off the right triangle things.
So wouldn't it be oh yeah. So it's not negative.
Yeah. But good point. I want to make it on video. If it was in the third quadrant or fourth quadrant, remember that would be a negative root 2 over 2. Yeah. You could also always draw your special right triangle in like the proper position. Like you could have drew it like upside down or something like that to help you visualize it, like we did in like these type of problems. All right, put another one. Evaluate cosecant of pi over 3. So cosecant is that's the reciprocal of sine.
That's your cousin, though,
No.
So this one is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite.
Isn't it sine of 3 pi then? Just flip it?
No. Inside would be the same. The results are reciprocal. Cosine x is the reciprocal of sine x. It's not sine at 1 over x. You don't flip the inside of the parentheses. No. Yeah. So with that in mind, if we could find sine, we could find cosecant.
Isn't it 1 over?
So would it be negative 60 then?
Technically, it's 1 over. That's what you want.
So would it be, since it's 1 over 60 for the degrees, would it be negative 60?
So this one would be pi over 3. It's not negative. No, not negative.
Okay.
This is pi over 3, which is going to equivalent to 60 degrees.
Yeah.
All right, 60 degrees opposite over hypotenuse. But this is cosecant. So instead of opposite over hypotenuse, hypotenuse over opposite. So in this case, it's 1 over, was it opposite? Hypotenuse over opposite. So across 60 is root 3 over 2. In this case, you reciprocate it, 2 over root 3. But you have to rationalize it. 2 root 3 over 3.
Wait. Why?
No.
Why is it 1 over root 3 over 2?
1 over root 3 over 2? It is 1 over root 3 over 2.
So why is it the 60?
Oh, so we figured out 60 degrees. So at 60 degrees, if I'm standing here, my opposite is, and my hypotenuse is,
1.
so it's hypotenuse over opposite, 1 over root 3 over 2.
Oh.
Which,
1 over sine.
yeah. Oh, 1 over sine. You could also see it like that perfectly fine.
You don't make sure first to hear everyone for the outside. You locked up.
No.
Coach, I expose you. I expose you, you.
All right. Next one.
Dan is gay.
Next one and last one.
Then Johnny.
Give me two values
I was crushing it, man.
where cosine of theta, give me two values of theta, I should say, where cosine of theta equals root 2 over 2. Yeah, give me two thetas where cosine of theta equals root 2 over 2. Actually, let's do negative root 2 over 2. Let's illustrate a big point. All right. So, in this situation, remember, all students take calculus. So first off, it's negative.
So it has to be
It has to be in,
either the second
and
or third.
good. It has to be here or here. The reason is cosine's positive. So this can, or cosine's positive in these sections. Then what you need to do is make it 40, or then you got to figure out what causes root 2 over 2. If you remember our right triangles from previously, oh wait, 45 degrees causes root 2 over 2.
Right.
So I want what is the equivalent to the 45 degrees in quadrant 3 and what's equivalent to quadrant 4 or quadrant 3.
So 225 in quadrant 2 and no, yeah,
That'd be quadrant 3.
in quadrant 3 and would it be 135?
Good.
Yeah.
So, and just to show how you would do that, again, you remember we did these 180 minus theta. In this case, I know it's 45. So if I want to figure out this, I'm plugging it in for theta in this case. So 180 minus 45 is 135. So that gets me one answer. And this one, it's theta plus 180. So I know what my theta is, 45. So 45 plus 180 equals 225. And that applies to 30s, 60s, or 45s. So you can do the same thing, okay? So this one, you got to take into account if it's positive or negative, and then take into account of the fraction separately. There was like two separate parts to that.
It was positive.
If it was positive, then your two answers would be, I'll do it in red here. Your two answers would be 45, because that would cause a positive situation. And then over here, you could technically put negative 45, or you could put 315, which in this section, it's 360 minus 4 theta.
Oh, so you're just doing those things.
Yeah, you're kind of doing it in reverse, basically. Because I'm telling you the answer is negative root 2 over 2. What causes that answer? And then you do it in reverse, effectively. Okay. That's pretty much it for the test. Know your unit circle. You'll be, if you remember unit circle or know how to use the triangles, you're pretty golden. That's the hard part, I would say, the non-calculus.
Have a great weekend. Are you gonna do a hard angle elevation question?
A what?